Okay, now that you have learned how to divide with polynomial long division, there is a shortcut. It can't be used all the time, so it is still important to understand what you just looked at, but there is a shortcut that works really nicely in certain situations, and it's referred to as synthetic division. It is a shortcut that can be used as long as what you are dividing by, as long as your divisor is something that is linear and that it is just x minus a number or x plus a number. So you can do it if you're dividing by x plus 3, you can do it if you're dividing by x minus 4. As long as you are dividing by a simple linear binomial, this shortcut will work. It's going to take me a second to explain it, but then once you start to get used to it, I think usually most students love the shortcut because once you get comfortable with it, it will go very, very quickly. So here's how it's set up. So you're going to take your dividend, all of this, and instead of writing the entire thing down, you're just going to write the coefficients of each term. You're going to create kind of, I sometimes call it a box, but it's not really a box. You're going to create like an L shape. You're going to write down, going across this L shape, you're going to write down, I have 1x cubed, I have negative 14x squareds, I have 51 x's, I have negative 54 constants. So that's what you're going to do across the top. You're going to write your coefficients across the top of this. Again, I usually call it a box, but it's definitely more of like a long L shape. Outside of it, over here on this side, you are going to put the 0 of the divisor. What that means is you're going to see what makes it equal to 0. So what makes x plus 2 equal to 0 is negative 2. So that is going to be the 0 of the divisor. So you probably want in your notes to just kind of jot down the overall setup so that when you set them up, if you set them up correctly, they will go very quickly once you do these. Here's how this works. The very first number in your L, so this very first number is just going to drop down. Absolutely nothing happens to it. You just drop it down. You are then going to multiply the number out here. I don't want to do that. Hold on. I want to highlight it. No. Hold on. Let me get it back. Trying to highlight. So, sorry, that's a 1. So you are going to multiply this number here by this number here. So you're going to multiply those two together. You get negative 2, and you're going to put that result under this value. Then you are going to add those numbers together. So you have a negative 14 and a negative 2 is negative 16. Then you're going to repeat that process. You're always going to be multiplying this by whatever's down here. So negative 2 times negative 16 is 32, and you're going to put that result in the next slot. And then you're going to add those two numbers together. And then you're going to go back to the negative 2 and multiply. So negative 2 times 83 is negative 166. And then you are going to add those two values together. So negative 54 and negative 166 is negative 220. So a good way to think of it is you're always multiplying diagonally, and you're always adding up and down your columns. So multiply and add. Here's what your answers mean. You have all these answers, and this is what's happening. This last value is your remainder. This value here is your constant. This value here is your x. And this value here represents your x squared. So your answer is x squared minus 16x's plus a constant of 83 with a remainder of negative 220 over x plus 2. So again, you are setting up this box or this L. You are multiplying diagonally. You are adding vertically. And each number that you get underneath this L shape will represent a term in your answer. Obviously, you're going to need to see a few more to have it make any sense at all. Here's kind of a summary. So if you kind of want to either take a screenshot or jot down some key things, you can only use this when you are dividing by something that's x plus or minus a constant. The number that you put outside of the box when you do it is the number that makes it 0, makes the divisor 0. The last number you get when you're all done is the remainder. If you get a 0 at the end, that means there's no remainder, and whatever you're dividing by is a factor of the function. So here we go. So I'm going to write my coefficients. I have 1x cubed, 2x squareds, negative 6x's, and negative 9 is my constant. And I am dividing by x plus 3, so negative 3 is going to go outside of my box. The first number drops down. Then I multiply diagonally. So I'm going to multiply negative 3 times 1. I get negative 3. And then I'm going to add that column together. 2 plus a negative 3 is negative 1. Then I'm going to repeat. Negative 3 times negative 1 is 3. And then I'm going to add that column together. Negative 6 plus 3 is negative 3. Then I'm going to multiply. Negative 3 times negative 3 is 9. And then I'm going to add that column together and get 0. That tells me that we have a remainder of 0. My answer, so this is my constant, this is my x squared. So my answer is 1x squared minus 1x minus 3. No remainder whatsoever. That means that this is a factor of the original polynomial. So it is a factor of this because it divided evenly with no remainder. Let me show you a couple more. I want to show you this next one because it has something special in it that's really easy to mix up. Before you start making your little synthetic box, notice in this polynomial, we are missing a term. We have an x cubed, the highest power is 3. We do not have an x squared. So when I set up my synthetic division, I have to have a placeholder, just like I did with the regular long division. So I have 1x cubed. I have no x squared, so I'm going to put a 0. I have negative 56x's, and I have 56 as my constant. So your 0 has to be used as a placeholder, and it is so easy to forget. And if you forget your placeholder, all your columns will be off, and your answer will be completely different than what it's supposed to be. And then the number that I'm putting outside is what makes this equal to 0, which is 7. So I'm going to drop down my first number. I'm going to multiply diagonally. 7 times 1 is 7. And then I'm going to add vertically. Then I'm going to multiply diagonally. 7 times 7. And then I'm going to add vertically. And then I'm going to multiply diagonally. And then I'm going to add vertically. Again, it gives me a 0 remainder, which means that it is a factor. So I have a remainder of 0. So my answer is I had 1x squared. I had 7x's and a minus 8. Another thing to keep in mind, when you divide x cubed by x, this first term is always going to represent your x squared. Every time I do a division like this, it will drop the power down by 1. So if it starts out as an x cubed, when I divide, my answer is going to be an x squared. Let me show you one more. This one, I don't think I need any placeholders. I've got 1x to the fourth, negative 2x to the thirds, 1x squared, 1x, and a negative 1. And I am dividing by x minus 1, so 1 is my 0 that I put outside. I'm going to drop down my first value, multiply 1 times 1, and then add that column. Multiply 1 times negative 1, which is negative 1, then add that column. Multiply 1 times 0, which is 0, then add that column. Multiply 1 times 1, which is 1, and then add that column. That is my remainder. So starting here, since I had an x to the fourth, this first term will represent an x to the third. So you have 1x to the third. You have negative 1x squared. You don't have any x's. If you want to write 0 x's, you can, or you can skip right over it. You do have a 1 that's a constant. So there is my quotient. And again, it had no remainder. So that is a quick overview of how you do something called synthetic division. It is way faster than long division. The reason that we do long division, though, is there are circumstances where synthetic division doesn't work. We have to divide by x plus something or x minus something. But it gives you an idea of the other way that we can divide polynomials.